Alright, here's just a few more things to wrap up direct and inverse variation. Part 1. Label the following as an example of direct or inverse variation. Remember the formula for direct? Label the following as an example of... Alright, the formula for direct is y equals kx. And remember, you could also solve that for k. So k would be y over x. The formula for inverse variation is y equals k over x. And if you solved that one for k, it'd be k equals xy. Alright, so here we go. We have y equals 2 over x. So 2 is your k value. So it fits into the formula of inverse. So this one is inverse variation. Number 2, y equals 1/2 x. 1/2 is your k. So y equals kx. That one fits into direct. Number 3, you need to be careful. In this one, k is 5. So when you multiply xy and it equals k, that is inverse. You could also solve it for y, so y equals 5 over x, and that might make a little bit more sense to you that that is inverse. So I would solve it for y. Alright, and number 4, when you solve it for y, you get y equals 2 minus x. This one is neither. Remember, for direct and for inverse, you're multiplying or dividing. There's no add and subtract for variation. Alright, part 2, practice EOC questions. A marathon is roughly 26.2 miles long. Which equation could be used to determine the time t it takes to run a marathon as a function of the average speed s of the runner, where t is hours and s is miles per hour? So you have 3 variables. You have time, you have speed, and you have 2 variables, and then you also know the distance is 26.2 miles long. Okay? So we have a distance, we have speed, and we have time. There's a formula that you use a lot in science, but it also comes up in math as well. Distance equals rate times time. And that's just kind of common sense too. The distance that you've gone in a car, the way you can find that is by taking your rate, which is your speed, and multiplying it by the time you've been in the car. So if you're going 50 miles per hour and you've gone for 2 hours, then your total distance would be 100 miles. Okay, so I'm going to replace the S with an R. Instead of using rate, they're using speed. Okay, I also know the distance is 26.2. So 26.2 equals ST. If you look at your answer choices, all of them have been solved for T. So if you get T by itself, you would have to divide by S. So 26.2 divided by S, and that is D. Alright, 2 more examples. Analyze the given graph, which models the number of hours, H, to complete a 12-hour job as being inversely proportional to the number of people doing the job. So they tell you right here that it's inversely proportional. Alright? And your X is people. Your Y is hours. And it's a 12-hour job. That is your constant. That is your K. Alright? Well, if it's inversely proportional, then K equals XY. And your X is people. And your Y is hours. And we have our 12. Alright? Let's see if that was one of the answer choices. Yep. PH equals 12. That is C. Alright? Last one, number 7. The force F acting on a charged object varies inversely to the square, that's going to be really important, of its distance r from another charged object. When the 2 objects are 0.64 meters apart, the force acting on them is 8.2 newtons. Approximately how much force would the object feel if it was at a distance of 0.77 meters from another object? All right, so I'm going to set up the formula first. The force F varies inversely, so that's going to be equals K over the square of its distance, so that would be R squared. Okay. All right, so they tell you right here, they give you the first number, 0.64 meters apart. Meters is a distance, which they're using the letter R for. I don't know why, but they are. So 0.64 goes down there. The force is 8.2 newtons, so that goes over here, and I don't know K. So the first thing I'm going to do is find K. Well, you would need to multiply both sides by 0.64 squared. So you get K equals 0.64 squared times 8.2, and I get 3.3587. Just write it all out to start with. Okay. All right, what's the question asking? Is it asking for K? No, it's saying approximately how much force would the object feel if it was at a distance of 0.77 meters. So here's my formula, and I don't know how much force. I'm trying to find that. So F equals. Now I know what K is, so I'm going to plug that in. 3.35872. And R squared. Well, now my R is distance. Now my R is 0.77. So 0.77, and you have to square it. You have to square anytime you're using a distance in this problem. All right, so I'm going to take what I got here and divide by 0.77 squared, and you get 5.66. So the force is 5.66 newtons, which is answer choice B.